Hi everyone, we're here to present our value proposition for a biocompatible surgical mesh for hernia repair.
I'm Nick.
I'm Kristen.
And I'm Emily. Every year in the United States, there are approximately 800,000 inguinal hernias. 80% of these cases are ambulatory, meaning that they require emergency surgery. Our device is catered for gastrointestinal surgeons and emergency room surgeons to use in the OR.
And with that said, the gold standard for this technique is a prosthetic mesh that is implanted over the abdominal cavity using laparoscopic surgery techniques. Here, 3 1 to 2 centimeter incisions are made, which allow for faster recovery time.
There are problems with this approach, however, chief of which is the risk of adhesion formation, so tissues such as the intestines adhering to the mesh in an undesired fashion, leading ultimately to intestinal blockage, and another risk that's posed is infection induced to these surrounding tissues. The meshes themselves are categorized into high weight and low weight meshes. The high weight meshes have an unnecessarily high ultimate tensile strength, really unnecessary for the forces that play in the abdominal cavity. And these meshes also have the highest risk of adhesion formation, so a lighter weight mesh is desired. Lastly, there's also an issue with mesh migration, so where the mesh can withdraw and move away from the surgical site, allowing for the hernia to ultimately recur, again, an undesired response. For our approach, we're looking to keep with the mesh design, specifically a lightweight mesh, where we're going to regionally coat it with an RGD peptide on the non-visceral side, allowing for the abdominal peritoneum to ingrow into the mesh, preventing it from migrating and ultimately anchoring it to the surgical site. We're looking to passivate the opposite side, so the visceral side facing the abdominal cavity, preventing adhesions from occurring and ultimately preventing problems such as intestinal blockage and fistula formation. We're looking to keep biocompatible material that's been used in the past, so polypropylene. We're looking to maintain compatibility with the laparoscopic procedure that surgeons are familiar with. And we're looking to apply barbs to the non-visceral side, again, working with the RGD peptide to help anchor it to the abdominal peritoneum. So as you can see here, it is a mesh design. Specifically, it's a unit cell design, so I guess the ultimate limit of size that would be necessary is 9 by 6 centimeters. This would allow the surgeon to cut it to size of that without any decrease in function. There would be barbs on the non-visceral surface preventing migration, as you can see here in the blown up image. There would also be an RGD peptide coating on this side, allowing for cellular induction, again anchoring it to the abdominal peritoneum, preventing migration. And lastly, to combat adhesion formation, we'll coat the opposite side with albumin, passivating it, preventing any sites where adhesions could form.
Benefits for our device include that it can be delivered laparoscopically, so the surgery again is less invasive and has a lower recur rate. Our device also promotes the healing of the inguinal canal itself, and the design prevents mesh migration, and it decreases patient discomfort through the use of barbs. And as Nick mentioned, it is a unit cell design, so it can be customized by the surgeon for the patient. Costs for our design include the downside of laparoscopic surgeries, so they take longer, they're more expensive, and they're harder for surgeons to perform. Our device is delivered through surgery, so there is always a risk of infection, and it is a Class 3 device, so it's a lengthy FDA application process.
The current competition for meshes on this market is the first Medtronic. It has over 5,000 microgrips and it's 40% absorbable. With this, it is not able to be adjusted once implanted, so the surgeon has to make sure it's perfect. And it has inconsistent degradation rates depending upon patient demographics such as lifestyle, age, and health. The Ethicon strip is porcine derived, which could conflict with people's viewpoints or allergies, and as well as the regionally inducive design. It has an open pore structure which may not benefit the patient. Finally, the barge structure is 60% lighter and is tailored to shape and size, both of which are mechanically changed with the device as it's implanted, and this could hurt the patient down the line as they grow or change in height and width. Thank you.
Thank you.